Yes, so indeed, this is very interesting. Those tools, they enable you to learn. This is very, very important. And then you got some tools to actually assess whether or not you have some undefined behavior in a piece of code. The tools you would start to do that would be sanitizers. Here again, you have many sanitizers, including open source sanitizers such as Valgrind, Purify, UBSAN. Those tools are going to detect memory leak, buffer overflow, like off by one. It's definitely a good way to start. If you want to extend those tools, you can couple that with fuzzers. That's definitely a good idea as well. This is a dynamic analysis. So you're performing some tests and you see what is happening. You can start using TrustInSoft Analyzer at level 1. At level 1, TrustInSoft Analyzer is like a sanitizer, but an exhaustive sanitizer. It relies on the formal method. And because of that, we're able to detect all the undefined behavior in a test campaign. So that would be the dynamic analysis. If you want to detect more things, you can go to static analysis. Without doing an execution, you are going to get some new potential location where there could be a threat, there could be an issue. And then what we do at TrustInSoft is we apply a formal method, we apply mathematical guarantee, so we can detect exhaustively all the undefined behavior. So it goes one step further, and at the end of the day, you're able to guarantee, for instance, that you have no buffer overflow using this static analysis, which relies on formal method.
Yeah, humanity grew up from the animals because we made tools. So actually what you are repeatedly do, or which can extend your arms, or which can improve your physical capabilities, that's what we call tools. And within secure coding, we also have those tools, which can focus on those issues that you don't have capability to. So for example, when we are implementing some piece of code and we are focusing on the actual functionality, what it should do, and we just discussed that we should also focus on what it shouldn't do, or what special circumstances in which it will behave in a malformed way. So that's why we can have tools which can discover those very particular conditions in which algorithms will do something completely different than we about to do. And because those tools have this other way of thinking, discovering malfunctioning possibilities, that's why we can call them testing tools, or we can call them analysis tools. And practically they work pretty well today. But the question is whether you know how to use those tools. Because at the end of the day, the tools will say to you that something can work wrong with this particular code, but you have to know how to correct it. And that's where secure coding comes into the picture, because if you just got a warning message, if you get an error message, you should know how to correct that code.